let's understand what the exactly architecture we have designed for this application. So this is our basic application architecture which we have designed. First of all, we have a web application, which is our main website on which our download links, our versioning of software will be provided to the user. It will be a simple web application designed in React, TypeScript, JavaScript, and deployed on AWS. We have our privacy policies and download section in it. We are also providing some analytics from our side, as how many number of disks we have created, how we have cleaned it, what type of standards we have used, what are our insight from it, etc. We are also provide API integration for various cleanups to identify to what we can say verify their cleanups from our website. Then where our users are basically system architectures or system administrators or normal users or repair shop vendors like us. They will either have a executable file which they have downloaded from our website, or secondly they can have a bootable flash drive, again, which is made using the downloads which they have downloaded from our website. These executable files and Alpine Linux will be included in both these cases. So Alpine Linux is basically the environment in which we are setting up our entire application. Our front end of our application includes a basic GUI which we have developed using React and TypeScript. A GUI, this GUI will be used for analytics to display various user preferences, to take inputs from user regarding the number of drives, drive path, etc. Then we are using Tori. So Tori is basically what we can say a messenger between our front end and our back end. Tori will be provide a intercommunication between our front end React and our back end Rust. Then we have a backend in which the entire magic is happening, which is in Rust. So Rust based backend is very useful for data abstraction and to what we can say to keep everything very low part. Also, I like to mention that the entire Alpine Linux architecture sum up in 128 MB. So this entire project will be sum up on approx 300 to 400 MB, which is by the way very much lesser from our competitors and current available solutions in market. Okay, so let's jump back to Rust. So what we are doing in our based backend? First of all, we are detecting the device which are drives available in my PC. Once the drives are detected, we are performing data sanitization on it. There are multiple layers of data sanitization. There are multiple techniques and technologies we have used for sanitization, multiple layers of erasure, multiple layers of rewriting is used to ensure that the entire data is clean and it can't be recoverable at any time in near future. We are also providing the feature of real-time monitoring in which the real-time cleanup graphs logs will be available to user whenever the cleanup is happening. This is very useful for user as to check what cleaning process is continuously going, how much time it will be take, and related details to it. We are also providing signed document, of course, which will help user to verify later that this drive is cleaned using some hash values. This will be available to our website, so whenever a certificate is generated, user can verify that certificate from our website. Then there will be a log generation, there will be analytics before cleaning up. This log generation help system administrator to check what kind of data was cleaned at what time, what specific time, who was responsible for cleaning, how he cleaned the data, what amount of data was cleaned during the entire process, etc. We are also integrating a AWS service known as SES, that is simple notification service or simple email service, which will be used to collect these logs and which will be also used to notify users whenever the entire cleanup process is done. This SES will be used to collect the logs, and it will be used to store it on our website on user login, and that's it. So that was the basic architecture we have designed for this, for our project. We are using various technologies such as React, TypeScript, JavaScript, Tori, Alpine Linux, Rust, Rufus, then there is a Next.js, Recent, etc. And we are ensuring that the entire architecture is lightweight, it is scalable at most cost, the environmental, the cross, it provides a cross platform support on various systems like Windows, Linux, etc., and it follows the NIST compliance of erasure with a cryptographic proof provide for verification of cleanup. So that's it from our side. Thank you.